Hello, today we will learn how to write a paper uh, for IEEE conference. So first we have to download the IEEE template. So I'll search IEEE conference template, LaTeX template, and from this site I can download the template and LaTeX bibliography file. So I have already downloaded those files. So two files, zip file conference LaTeX template and IEEE run bst2. So all our style file, BibTeX style files are there. So first I will upload. So first I will go to new project, then upload project, and I will upload the conference LaTeX template. I can drag and drop. So next I will upload all the BibTeX style files. So upload here. So I will upload all these. So now I will edit that LaTeX source file, text file. This is the text file. So this is the text file. We have to edit that file. So first, how to set the title of this paper. So first, for example, I have a paper. I have worked on heart disease. So using machine learning. So heart disease prediction using machine learning techniques. So now I can recompile it, and the title is fixed here. So in the right hand side of the window you can see that PDF is generated, and suppose we don't have the subtitles, so I will block it. Then I will set the author name. So here I can write my name. So name has been appeared here, and now I'll change the department name. Department of Computer Science and Engineering. My department name has been appeared. Now I will set the organization name, University of Jaipur. And next, in a city and country, I will set Rajasthan 303-807, the country. So here I can set either email address or ORCID ID. So for example, xxxy@gmail.com. So here you can see that the author name along with its affiliations appear. Now suppose we don't need this fourth, fifth and sixth author, so we can block them or we can delete it. So now you can see that all the things here, that is introduction, so maintaining the integrity of the specification, so different guidelines are provided here, so you can take help from this. You can see there is table structure. Okay, so you can take help from it, you can create your own table structure, and for figure you can use that code. So first I will create the structure of this paper. So first section after introduction related to work. After that I'll put materials and method. After that I will place experimental setup. So here you can see the different structure, and next we will put the label for each section, because we need to reference this section later. Now in different section we need subsection. So for example, experimental setup we need subsection. So parameter settings, then we need PC configuration. So after experimental setup we need another section, that is results, and another section discussion. So here we do not we can comment all these tutorial contents. So for this I can use package comment, and I can block it, block the content. So in the next tutorial I will show how to insert the table as per our requirement, how to insert a figure, how to maintain the BibTeX for reference. Thank you. In this video lecture, I will show you how to insert a figure in the result section. So to include a figure, there is a code block is given. So this is the code. So we'll just copy it and paste in the result section. Now so you can see that figure is appeared here. Now what to do? We have suppose our own figures. So first we will upload to the overlay. So this is the upload button. Now we will drop the figure. Now this is your figure name. Just copy the figure name and we place here. We'll give the name. Now we'll change the caption. So the box plot of ML models accuracy box plot. So now you can see we need to adjust this figure. So here what can I do? So width equal to 2 inch, so I can increase the width. So here I have included the accuracy box plot of ML models. Now I need to refer this figure in the text. How to do that? So here I have used a label figure. So using that label I can reference that figure. So the accuracy box plot is provided in figure. So I use the reference command, reference over command ref, and so the figure name figure reference label will appear here. So you can see here the figure number is 1, and here I have cited that figure in the text. So you have to keep in mind that each figure should be cited in the text. So in the next video I will show you how to create different table structure. In this video I will show you how to create table. So it is the paper based on machine learning. So generally in machine learning paper we need basically two tables, one for training, another for testing. So for training we need mean training accuracy, standard deviation of training accuracy, and mean CPU time. So to do that, first we will copy the table structure provided by the IEEE conference template. So first I will copy that segment, that begin table, end table, and put it in the real section. So if I compile it, I will get that table structure. Now as mentioned that I need 4 columns, one for ML model name, second is mean training accuracy, third is standard deviation of the training accuracy, and fourth is CPU time. So now we will first create the training accuracy head, and under that head we will place 2 columns, one is mean and this standard deviation. So here I will put training accuracy, and another head is I'll put here. So I will use multi-column for that. So training accuracy has 2 columns, so I'll put 2 here, and then I need CPU time. So we can see that we have training accuracy column and CPU time. So in place of table I will put model. Now in the next I will place 2 columns under the training accuracy. One is mean, another is standard deviation. Here you can see that 2 columns mean and standard deviation under the training accuracy. Now what we will do, so model head you can see here, so we will adjust that using multi-row. So for that we have to include the package multi-row. and here what we'll do, I'll write multi-row. So how many rows? For 2 rows, and inside that I'll place so you can see model here. So now I'll delete that head here. So you can see only model mean, and also you can see that CPU time will adjust it for 2 rows. So here I can use the multi-row. So now here the C line 3, 2 to 3. So I'll delete here that sharp head. Now here you can see the column format I have done. Now I will put the data in the table. So first the model name, suppose MLP ampersand. So the second entry will put suppose 86.32 the mean, and the standard deviation suppose 10.13 for example, and CPU time it suppose 2.6. So you can see here I have entered one data item for MLP. Next I can do the same for other. So first I'll delete that multi-column, that portion. Then suppose SVM ampersand 98.24, and the standard deviation is suppose 1.46, and then training time suppose 4.5, and then I'll put another horizontal line here. So then recompile. So I have got that structure. Now I'll place another model. So DT ampersand now 97.26 and 1.5, and the computational time suppose 5 or 3.5 minutes. So put another horizontal line. So here you can see the double backslash for new line and then horizontal line. Then I'll do it for another model, random forest, and suppose it is 99.16, and the accuracy standard deviation 0.05 and 4.3, and then double backslash and then horizontal line. So here you can see that I have placed the data for 4 model. Now if I want to change the alignment of the model name, left alignment, so I will place it L. So L for left alignment, C for center, and R for right. Now I will change the caption of the table. So mean and standard deviation of training accuracy with mean CPU time. Okay, now here the label, so I have to give the label of the table, training accuracy. Now I have already told previously that whatever figure you use or table structure you use, you have to reference that table and figure in the text. So I'll write here the mean and standard deviation in bracket STD of training accuracy over 10 folds with mean CPU time are provided in table, again reference and the table level. So here you can see that the table reference are appeared here and the citation of the table provided by that way. So in the next video I will show you the table structure for testing accuracy. So we have created the table for training accuracy. Now we will create another table for testing accuracy. Now we will copy this table structure. So here I will put the caption maximum, minimum, mean and standard deviation of testing accuracies. Over 10 folds. So that caption I have set here. Now what I will do, I will change the table accordingly. First I will erase that portion. So first I will put the table header. The first will be the model name, then the column for maximum, minimum, mean and standard deviation. I left that block column, and next I will put, suppose, first accuracy. In short I am writing, then sensitivity or recall, then specificity I am writing in short, then precision, then F1 score, so I am writing F1, and then geometry mean, and then FPR, false positive rate. So here I have 1, 2, 3, 4, 5, 6, 7 performance metrics. And then horizontal line. So we have total entries 1, 2, 3, 1, 2 plus 7, so 9. So we have to set the alignment here also. So 7, we need additional 2. So you can see here that we have put the number of columns and the alignments. Now what we will do, we will enter the data. So now actually for different model we have 4 summary statistics, that is maximum, minimum, mean and standard deviation. So 4 rows for each model name. So that's why I will use again here multi row. So 4 and the model name MLP, and then max, then the maximum value over 10 folds for each matrix. So suppose accuracy 99.01 and recall 93.23, and then specificity suppose 90 or 23, and then precision 92.01, and then F1 score suppose 85.02, and then geometric mean suppose 80.20, and then false positive rate suppose it is 0.7, 9.77. So again 2 backslash and horizontal line. So I will place other data. So just I am copy paste that. That is for mean. So here you can, so first I complete all the 4, then this is for mean, and this is for standard deviation. Now here you can see that horizontal line cross this model column, so it cross the MLP. So here I will, what I will do, I will use the cline command and from 2 to 9 in place of horizontal line. Okay, and do the same for other. Now you can see we have adjusted that MLP and its data. Now we'll do it for other. So I'll copy paste the same code. So in place of here I can write SVM. So you can see in that way we can do that. So you can enter the data later on, but I have created the table structure first, and then I'll create the, I'll enter the data for decision tree DT, and then I'll do it for random forest. So you can see there is 2 lines, horizontal lines, so I will delete that one, last one. So here you can see that table structure has been created, and you can edit all the data in any way. So now I will edit the label. So this is for testing. Now I will enter a text, that is so maximum, minimum, and standard deviation. Of testing accuracy over 10 folds are provided in table with a table. So you can see that table will be cited in the text. So here you can see that maximum, minimum, mean, and standard deviation of testing accuracy over 10 folds are provided in table 2. So now here you can see that it cross the column width. So we can adjust it, okay, by specify the length of the column. So here what we'll do, suppose if I set P 0.5 semi, and I can align that column also. So I have adjusted that, and next I can left align all the maximum, minimum, mean, standard deviation, and I can also reduce it. You can do it by yourself. So using P in bracket, the width of the column you can put, and you can adjust the table length. So here you can see that it cross the width, text width of the column, so you can adjust it. So if I write in place of std dot d in dav, so if I write only sd, if I put only sd, so it is reduced, and now I can, if I adjust f1, so for f1 1 2 3, f1 1 2 3, so p 0.5 semi, for example, I'm trying to, okay, so it is adjusted. Then I can put for precision the same, or I can put for fpr. So it is so now we have to reduce the size again, so we can use for other also. So So here you can see we have adjusted the table width. So for recall we need to increase the space, so you can see now you can see that the table width has been adjusted and also it is easily readable. Okay, so we have completed the table for testing accuracy. So in the next video I will show you how to do the reference, how to use BibTeX. So in this session I will show you how to make a reference list, how to manage the reference, how to cite the reference. So here you can see the guideline that how to do cite the paper research article. You can see cite B3. Okay, so like that. So do not use reference dot cite like that. So clear instruction is given here. So you have to follow that. Now another thing is that here begin the bibliography and end the bibliography. In that block, the reference are given manually, but we can do that easily using BibTeX. So first I will make comment of that. So, so how can you do that? Bibliography, style. So IEEE transaction. Next, bibliography. So here we have to give the file name .bib file name. So we'll create a blank file here, new file with reference.bib with that name, and here I will give the name bib file. So if I run that, you will see that the reference section is created. Now, as there is no reference here, BibTeX here, so there is no reference list. So first we will enter the BibTeX. So I will search in IEEE Explore. So as per my topic name, I will search that RDGs. So I'll take that one first. So you can see here that cite this. Okay. So click on that cite this, and you can see that BibTeX. So BibTeX here. So this is the BibTeX structure for proceedings. You can copy here and paste here. Okay. So now how to, if you compile that, so these people will not appear here. So first we have to hide this using that key item. So I make copy of that, and for example in reference related work section I will do that. So the supervised ML models have been used in and this is reduction. Then you have to use the command cite, and I'll just paste that code and compile it. You can see here that the reference, that conference paper, is appeared in the reference section number 1, serial number 1, and here you can see the supervised ML models have been used in hard degree prediction, reference number 1. So we have cited number 1 paper in our reference list here. Now we can take another paper. So again, cite this. If you click on cite this, you will get that, and then BibTeX, and you can copy, and in the reference link you can paste here. So I have copied the key item, and then here I can write a clinical support system has been developed using ML model. Okay, and then use the command cite and paste that one. So you can compile it. Now you can see here the reference list. In the reference list is 2. So here it is appeared number 2. So in that way we can, so there are different structure for conference proceedings, journals. So you can go directly to the journal site and copy the BibTeX and paste here, and you can cite that paper using that key item. So later on I'll see another different options, different style of writing, and in the next I will show you how to write the paper in an efficient and effective way, okay, so that it is error free.